Welcome everyone. In this video, we are going to talk about recursive functions and see a few examples. So let's get started. Let us first understand what is recursion. Recursion is a programming technique that allows us to break down a complex problem into smaller, simpler parts which are easier to solve. Once we have found the solution of these sub-parts, we can combine them to arrive at the solution of the bigger problem. This is why recursion is quite useful in solving real-life problems. Next are recursive functions. Now, recursion can be implemented with the help of recursive functions, which are nothing but user-defined functions only. A recursive function is a function that calls itself again and again until a base condition is reached. This base condition is what is responsible for stopping recursion. If there is no base condition, then the recursion would go on indefinitely. Now, in order to understand recursion, I am going to take the classic example of factorial calculation. I am sure you must have heard of how to calculate the factorial of a number. So, in this table, we can see that factorial of 1 is equal to 1, factorial of 2 is equal to 2 multiplied by 1, giving us value 2. And in the same way, we can calculate the factorial of all bigger numbers. So, this is the general formula for calculation of factorial of a number. Now, the same thing can be implemented using recursion also. Let's do it. Now let us suppose that I want to calculate factorial of number 4, then it can be written as 4 multiplied by 3 factorial, which requires calculation of 3 factorial, which is written as 3 multiplied by 2 factorial, which further requires calculation of 2 factorial, which is equivalent to 2 multiplied by 1 factorial, and finally we have 1 factorial equal to 1. Now this 1 factorial equal to 1 serves as the base condition, and here you can see that we have divided the bigger problem, which was to find factorial of 4, to a smaller problem where we are just finding factorial of 1. In general, we can write this equation as n factorial equal to n multiplied by n minus 1 factorial. Now that we have found the solution to this base condition, we can take its solution to the next higher step, and here we can generate factorial of 2 equal to 2, and then we can take this 2 to the next higher step in order to find factorial of 3, which is equivalent to 6, and finally we can take 6 to the next higher step in order to find factorial of 4, which is equal to 24. So this is how we can calculate factorial of a number using recursion. Now let's implement it using a recursive function in IDLE. So guys, I am inside IDLE right now, and here we are going to define our factorial function. I will pass here a parameter n, which signifies any number for which I want to calculate the factorial, and here my condition is that if value of n is equal to 1, then in that case we will return 1, that is factorial of 1 is equal to 1, else we will return here n multiplied by factorial of n minus 1. That is it, the function is defined, and now let's call this function for factorial of 4. So in this case we got 24 as the output. Similarly, if you want to calculate factorial of number 5, then the result is 120. So try this function on your own. Another classic example of recursion is that of Fibonacci series. A Fibonacci series is a series of numbers such that every number in this series is the sum of its previous two numbers. Take a look at this series. Here, the first two numbers 0 and 1 are always fixed. We begin our calculation from the third number. So here 1 is the sum of its previous two numbers 0 and 1. Similarly, 2 is the sum of 1 and 1, 3 is the sum of 1 and 2, 5 is the sum of 2 and 3, and so on. So guys, let us generate the Fibonacci series using a recursive function. Here the name of my function will be Fibonacci, and I'll pass here a variable n as a parameter to this function. My first rule is that if the value of n is equal to 0, then the function would return 0. Otherwise, if the value of n is equal to 1, then the function would return 1. So these two conditions represent our first two numbers. That means first number is 0 and second number is 1, which are always fixed as I mentioned. Now for every other number, we will have else part where we are saying that the function would return Fibonacci of n minus 2 plus Fibonacci of n minus 1. Now that the function is ready, let's call it for different values of n. So here I am calling Fibonacci for value 3, and Python interpreter takes the value of n equal to 3, which is neither equal to 0 nor equal to 1, and runs this last condition. So in this case, the Python interpreter runs the last condition where it says Fibonacci of 3 minus 2, which is equivalent to Fibonacci of 1, plus Fibonacci of 3 minus 1, which is equivalent to Fibonacci of 2. Now these two are again calling the same function but with values of n equal to 1 for this one, and for this value of n becomes 2. So this is recursion here, and these values will be calculated and the sum will be equal to 2. Let's see another case. Here I am typing Fibonacci 4, and here when you press enter we got the fourth value as 3. In this case also Python interpreter has taken value of n equal to 4. So this last condition executed where it says return Fibonacci of 4 minus 2, which is equivalent to Fibonacci of 2, plus Fibonacci of 4 minus 1, which is equivalent to Fibonacci of 3. So in this case both of these will be recursively called, and then the values will be calculated and summed to return value 3. Let's print this series in the range, let's say how many numbers are there. Let's say for 10 numbers I want to check what is the output for this function. So here I will type print Fibonacci, and then I will pass here I as the argument name, and I will press enter. So here my Fibonacci series is generated. Now if I want to generate this series in a single line, then I will have to repeat this function, and here I will pass an argument and equal to, and here I will provide some space, and now when I will generate this, all the numbers are in the same line. That's all guys for this video. Here are a few practice problems for you guys. If you have any queries or comments, please mention in the comment section below. I would love to hear your suggestions and feedback. If you found this video helpful, then don't forget to share it with your friends. Also, like and comment on this video and subscribe my channel Programming Horizons for more videos like this.